Hey guys, welcome back to the laboratory. In this video, we are looking at the properties of ionic compounds. By the end of this video, you should be able to identify and explain the properties of ionic compounds. So, let's go. Ionic compounds are held together by strong electrostatic forces of attraction between oppositely charged ions. For example, lithium fluoride is an ionic compound made up of positive lithium ions and negative fluoride ions. The attraction between opposite charges and the repulsion between like charges causes the ions to pack together in a repeating pattern called an ionic lattice. This ionic lattice structure can be used to explain the different properties of ionic compounds. We'll start first by discussing their melting and boiling points. Ionic compounds are solids at room temperature, and this is because they have very high melting and boiling points. To melt or boil a substance, the bonds within it must first be broken. Energy is required to break these bonds, and this energy is often provided via heat. Because the electrostatic forces of attraction between the ions forms a very strong bond, lots of energy is needed to overcome these. The more energy required, the higher the temperature, and thus, the higher the melting and boiling point of that substance. Ionic compounds are also great conductors of electricity if molten or dissolved into water. To conduct electricity, a substance must have charged particles that are free to move. When molten, the ions break away from the ionic lattice structure and are free to move and carry the electrical charge. Similarly, when dissolved into water, the ions dissociate from one another and are free to move and carry the electrical charge. In contrast, ionic compounds are poor conductors of electricity when they are solid, as the ions are tightly packed into the ionic lattice and are unable to move freely. Here's an example of how you may be assessed on this particular concept. Pause the video, read the question, and take your time to answer. I'll be waiting for you on the other end with the mark scheme. Question 1 asks for you to explain why the melting point of sodium chloride is high. Sodium chloride is an ionic compound, meaning the ions within it are held tightly together by very strong electrostatic forces of attraction. Energy is required to overcome the forces of attraction within sodium chloride and change its state. Because these forces of attraction are so strong, lots of energy is needed to overcome them, therefore explaining why sodium chloride has such a high melting point. Question 2 asks for you to explain why sodium fluoride is able to conduct electricity when it is molten, but not when it is solid. Remember that a substance will only ever conduct electricity if two criteria are met. Number 1, if there are charged particles within the substance, and number 2, if those charged particles are free to move and carry the electrical charge. When ionic compounds are solid, the charged particles are present in the form of ions. However, the ions are tightly packed into an ionic lattice and are unable to move. In contrast, when an ionic compound is molten, the ions break away from the ionic lattice and are free to move and carry the electrical charge. So, how did you do? Let me know in the comment section below. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!